Jasmine, and today I'll be sharing with you my experience with a project entitled Toying with Science, Preparing Future-Ready Teachers via the CoDIR Approach. Before I start, let me just walk you through the outline of my presentation today. So I will start first with the why of the project and the how of the project, then I'll briefly talk about my students' involvement, and then a little bit on the impact and potential of this project. To provide you with some background, this project is based on a course called Teaching Primary School Science, where it prepares the pre-service teachers to teach science at primary school level. So first, let me talk about why this project was initiated. This project sets out to address these issues, and I'm going to walk you through these three issues in the following slides. Firstly, concerning the disparity between what is taught and what is being practiced. Ladies and gentlemen, in a lot of reports, there has been a call to change the way universities are teaching. Universities should not be teaching in silo, but rather bridge what they are teaching in the university with what is being practiced in the industry. That is the same rationale we use for work-based learning, and previously what we heard about the 2U1I initiative, right? So in the case of teacher preparatory program, pre-service teachers previously are normally asked to act out their teaching and ask hypothetical questions to their classmates in class. Also, there is an issue of allowing opportunities for our graduates to think critically and creatively, which are both an important 21st century skills. Teaching, ladies and gentlemen, in this regard should be reflected as innovative fuse career and not just a routine-based teaching and practice. Thirdly, is on the declining trend of enrollment into science-related studies due to how students perceive the dryness of the subject. This has been raised by our Minister of Education and why he has advocated the STEM for All movement. There is a need, ladies and gentlemen, for science teaching and learning to be reflected in more interesting ways. Based on the issues discussed, the objective of my project, hence, is to get my students to innovate toys to teach science to real learners in schools. Now, let me share with you the approach used to achieve that objective. The approach I use is what I call the CoDIR Approach, or which stands for Conceive, Development, Implement, as well as Reflect. I will walk you through each of these stages. In the conceive stage, the pre-service teachers are briefed in class on the project, after which they are expected to research more on the science concept they wish to explore more on. They then, of course, need to discuss with their lecturer about the viability of their innovation before they start executing the project. Secondly, in the development stage, this is where ideas they gather through brainstorming as a group finally are developed into something tangible. So as you can see, this is an example of a toy from an idea on paper to being concretized as a toy that you can see on this table today, which can be used for teaching. And I'm happy to showcase all of these toys too, which went through the similar process. Yeah, and another one. All right, so thirdly, at the implement stage, the project presents itself in a formal science fair for primary schoolers held at an international school. A school science teacher who is a practitioner and expert evaluated the toy project from the teaching perspective. 15% weightage of the total assessment of cost was given to this industry expert. Now, by the way, the industry expert who evaluated the toy was recommended by the school, and she is a teacher with 10 years of teaching experience. She had taught in 3 private and international schools, as well as a winner of President's Award in 2016. And from the school's perspective, a teacher whose student participated in this science fair testified that her students had enjoyed the fair and how the toy are linked to the syllabus her students are learning, making them able to understand and associate their learning better because it was based on the experience of playing with the toy during the fair. And finally, students need to reflect on the team project to consolidate their learning experience and see how much they have progressed throughout the project in terms of learning. There's also a component of peer assessment where they need to assess their peers for their contribution as team players. Let me now talk to you about my students' involvement in this project. So I got my students to write out reflections, and respond to a survey regarding the effectiveness of the project. And the response was very encouraging. I've categorized them into these three categories, and there are examples for each. But I think it's more useful for us to just listen to the testimony given by Kavita, one of my students, here on her learning experience.
As this project needs us to develop a toy, the initial part was spent on researching a lot on topics we would like to teach with the toy we'll be creating. As a result of that, we understand the content better, and this understanding are then enhanced when we meet our lecturer to clarify things and to consult on the appropriateness of our toys. Then we get to meet school kids and teach them the concepts behind the toys we created. The whole journey was fun and it became more meaningful as the concept stayed better in my mind when I get to teach others instead of just memorizing the whole lot of scientific concepts.
Ladies and gentlemen, so it was quite obvious that these students find that the exposure to teach specific science concept to real learners in school helped her to experience what worked and what did not. So it helped also in collectively the students to develop their pedagogical knowledge on science. Sorry. So aligned to what Kavita has testified, Mr. Hellas, the licensed person who I was coordinating with in organizing the science fair, also mentioned to me that the school students find the fair enjoyable as they are able to participate and learn as well as interact with adults from outside the school. Let us now move on to the impact of this project. Let me talk about the impact of this project based on the learning outcome of this course because it will help us understand if this project really helps the student in attaining the learning outcome of the course. The first learning outcome focused on the learning theory and pedagogical principle, and analysis of data revealed that 25% more students are attaining grade A with 100% passing rate when compared to before the intervention. And this shows that more students are able to achieve the learning outcome of this course. The second learning objective focuses on developing the pre-service teachers' communication skill. And the survey given to the students showed that 86.3% are in agreement that the project helped them communicate better to science learners, while another 81.9% agreed that it has improved their overall communication skill. I also administered the survey to the respondents with these few statements on the survey, and the findings showed that their experience on the project has been very encouraging. The reflective write-ups that they came back to me were also very encouraging. So these are the examples of the reflective write-ups. Other than benefiting the main stakeholder, who is the pre-service teachers themselves, this project also engaged the important stakeholder, who is the industry and potentially the pre-service teacher's future employer. Because part of the assessment is done by school teacher and the science fair was hosted by the school, it provides a platform for interaction between the university student, the industry, as well as the university. Lastly, let us move on to the potential of this project. Firstly, the CoDIR model is able to be transferred into any field which require project-based learning, specifically at teacher training colleges and to in-practice educators at primary, secondary, and college levels. Secondly, a paper based on this project has been accepted for publication, and I believe that this would allow others to learn as well as apply as part of their practice. In terms of scalability, this project has already been scalable into a festival in collaboration with Ministry of Education, which was held on 17th of August 2019. If I may, let me just share with you a few photos from the festival. So these are the photos from the open category. Next are from the college university category. And then there's also students from school category. And I'm happy to share that my students have managed to get a gold, 3 silver, and 2 bronze from the festival based on the innovations that they have submitted from this particular project. Yeah. So before I end, probably it's just useful for me to share about my perspective in teaching using analogy. We know that being a medical doctor is a challenging vocation. Particularly if you misdiagnose a patient, it may cost that patient's life. You can say the same for an engineer. If you miss or ill design a building, it may collapse and it may cost somebody's life. But not many look at teaching the same way. If you misassess students or even take a teaching for granted, then it may break them or make them. Yeah. So as Ken Robinson rightly puts it, if I change my world and you change your world, together we are changing for a better world. And that's where the real transformative in teaching is happening together. Thank you very much.